going on a kind of safari, not into some jungle, but deep into the very heart of reality itself. We're going to take a look at the fundamental, indivisible bits and pieces that make up, well, everything you see around you, including you. It's probably one of the biggest questions anyone can ask. Let's forget about molecules for a second, even atoms. What are they made of? What are the ultimate building blocks of you, me, the stars, and everything in between? It's a question that takes us right to the very edge of physics.
And this is our map. Now, don't let it intimidate you. Think of it like a family tree of all of reality. Officially, it's called the classification of elementary particles. So for the next few minutes, we're just going to walk through it branch by branch, and I promise, by the end, it's all going to make a lot more sense.
Now, what's so cool about this map is that right from the get-go, it splits everything, all of reality, into two huge kingdoms. Over on the right, you've got the fermions. Those are the particles that make up all the physical stuff. And on the left, you've got the bosons, the particles that tell all that stuff how to act. So you've got matter and you've got force.
So, say hello to the fermions and the bosons. Probably the easiest way to think about them is like this. Fermions are the Lego bricks. They're the actual, tangible stuff of the universe. Bosons, on the other hand, they're like the cosmic messengers, carrying the rules that tell those bricks whether to stick together or to push apart. One builds, the other communicates. Simple as that.
So let's start with our first kingdom and see how this all builds up. We're going to explore the fermions, the actual particles of matter that create the solid world we all know and live in.
Okay, so inside this big fermion family, our first stop is a little group called the leptons. If you look at the chart, you can see there are a few members here, but one of them is an absolute celebrity in the particle world. In fact, it's powering the very device you're watching this on right now. And of course, it's the electron. The flow of electrons, that's what electricity is. It powers our entire lives. But the electron also has a couple of heavier, kind of unstable cousins called the muon and the tau. And then there's this super light, almost ghost-like particle called the neutrino. So there you go. That's one whole branch of the matter family tree. Now let's hop over to the other big branch of the fermion family, the baryons. So if leptons are kind of the lightweights of the family, then baryons are definitely the heavyweights. You'll find them all clumped together right in the very center of atoms. And right here, we find two more particles you have definitely heard of, protons and neutrons. I mean, these are the guys that make up the atomic nucleus. You've got protons with their positive charge and neutrons with no charge, all huddled together, forming that dense core of every single atom in existence. So, protons and neutrons, they build the stable, familiar world of atoms we all know. But the baryon family has a bit of a wild side. If we dig a little deeper on our map, we find this strange subgroup of particles that are super unstable. They just don't hang around for long. They're known as the hyperons. Our map shows 4 different types of these exotic particles. Now, don't worry about getting lost in the names. The really key thing to know here is that they're all highly unstable, much heavier cousins of the proton and neutron. They only pop into existence for like a fleeting moment in really high energy collisions, inside particle accelerators, or maybe when cosmic rays smash into our atmosphere. They're the wild, short-lived relatives of the matter family. All right, so that pretty much covers the matter side of our map. We've met the bricks. Now let's cross over to the other kingdom and meet the messengers, the bosons. These are the particles that carry the fundamental forces of nature. They are constantly zipping back and forth between all the matter particles, basically telling them what to do. They're the reason an electron orbits a nucleus. They're the reason the sun shines. So the most famous boson, as you can see right on our map, is the photon. That's the particle of light. Every single time you see anything, photons are literally hitting your eyes, carrying that information. The chart also lists gravitons. Now that's the hypothetical particle that would carry the force of gravity. We obviously know gravity exists, but actually finding its messenger particle, that's one of the biggest challenges in all of physics today. And the chart shows us a few more messengers. Down this branch, we have a whole group of particles, like pions and kaons, that are absolutely critical. They are the carriers of the strong nuclear force, which is this incredibly powerful glue that holds protons and neutrons together inside an atom's nucleus. Seriously, without these little messengers, every single atom in the universe would just instantly fly apart.
Okay, so we've toured both kingdoms. We've met the family of matter, the fermions, and the family of force, the bosons. So now let's zoom out and take a look at the whole map with our new eyes.
And there you have it. This brilliantly lays out the entire picture. It's not just some random collection of names anymore, is it? You can actually see the grand structure, those two main families, matter and force, and how they branch out into their specific groups. This is it. This is the complete cast of characters for the entire cosmic play, at least as we understand it right now.
And you've got to remember, this isn't just some abstract theory. The very act of you watching this right now is completely governed by these particles. The electrons zipping through the circuits of your device, those are leptons. The protons and neutrons that make up the atoms of the screen, baryons. And the photons traveling from that screen to your eyes, those are bosons. It's all happening right here, right now.
This map, what we call the Standard Model, is honestly one of humanity's greatest intellectual achievements. It's our best ever description of reality. But physicists know it's not the whole story. It's incomplete. It doesn't really explain